Okay, Chapter 7, Part 4. I want to talk today to you about calculate the mean from the confidence interval, a little about the t-distribution and the chi-squares, getting the samples, an estimate on the samples, variances, and then maybe talk about the flow chart at the end. So let's see if we can get all this done right quick. With the proportion here, the way that it works out is that if I give you the upper and lower values of the confidence interval, then to calculate the p, all you have to do is add those together and divide by 2. For example, in the example that we've been working with on the M&Ms, we said that there was 12 to 28, and so we could add those together to get 40 and divide by 2, and that tells us that our mean that we were calculating, that we were using, was 20. You can also do the same thing with the confidence interval, the estimate of E. Take the upper confidence interval, subtract the lower confidence interval, and divide by 2. To get the mean, you add. To get the confidence interval, the estimate of E, then you subtract to do that. Now, we spent quite a bit of time working with the confidence interval on the proportions. Turns out that the same thing we do with the proportions, we're going to do with T. This is going to be used to give us a confidence interval about a mean, which would be an interval value. You can go through and say that people in the class scored 70%. Well, what was the range? Well, the 95% confidence interval might turn out to be something like 62 to 78 or something like that. Now, so we can do that about a mean, and there's materials in the textbook about that, and so you should be able to pick up on that pretty quickly. Now, we also can get a confidence interval on the standard deviation. And to do that, we use the chi-square. Now, the problem with the chi-square is that the chi-square distribution is not a uniform, it's not a symmetrical distribution. When we use the t, it was a bell-shaped distribution, and we know from earlier work that the z-score, told you I wasn't an artist, is also symmetrical. That sure doesn't look very symmetrical to me. But trust me, the z-score is symmetrical. So the z and the t are symmetrical. Turns out that the chi-square is not symmetrical. So when we do a variance, we're going to find out that on one side it's going to be shorter than on the other side. That's when we're getting a confidence interval on the variance. It's just using the same formulas that we developed with the proportions, so it's not going to be I don't think it's going to be a real challenge for you, just going through and plugging in, working out the numbers to do that. At the end of the chapter, I do want to go over a flow chart that's there. And again, this is not intended to replace the material that's in the text. It's just to go through and to help to supplement some of the information that's there and give a little bit better explanation. Let me use this one. That's bright. Doesn't it wake you up, I guess? we have to decide sometimes whether we're going to use a normal or a t-distribution. So if n is greater than or equal to 30, if our sample size is greater than or equal to 30, then we can use the normal distribution with the margin of error that's given here. If the population standard deviation is not known, then we use the sample standard deviation. And again, hopefully you can see this. If you can't see this, then look in the book, or if you don't have the book that has this edition, then, or the edition that has this in it, then holler at me and I'll send it to you. Okay, that's yes. If the answer is no, then is the population normally or approximately normally distributed? Yes. If the variance is known, standard deviation is known, yes, then we can go back and we use the same formula that we had up here. If it's not normal, then we don't use the normal distribution or the t-distribution. We use some sort of bootstrapping method, and I gave some explanation of the bootstrapping method. It's a relatively new thing in statistics, but it's quite powerful. The only other place that we haven't gone is the population variance known. If the answer is no, then you drop down and you use the t-statistic. Now, it turns out that this is a situation that is used most commonly in the literature. Most of the time, we do not know the variance, but it is approximately normally distributed. So this is the last session on Chapter 7. Again, always interested in the comments about it. Help me to improve it. Thanks.